Are you feeling a little bit dirty? Or are you just kind of curious how this can come from this? Well, I'm here to tell you that. My name is Dennis Hunter, and welcome, class. It's nice to meet you here. I intend to show you my expertise in the matter at hand. I happen to be a soap maker for many years and amateur chemist. Both those two things make me super happy. So, let's start out. Soap is both hydrophilic and lipophilic. That word hydrophilic means water, hydrophilia, love. In other words, it loves water. Soap is attracted to water. It's also lipophilic, lipid meaning fat. It loves to bond to fat. It emulsifies it and lifts it. Soap, by its very nature, with existing in both a lipophilic and hydrophilic state, gives it its amazing cleaning properties. So, now, soaps are made from fats. Essentially, that's really all they are is salts of fats, fatty acids. As we see, it needs something to break that fat. If you just rub fat on yourself, you'd still be dirty. However, something like sodium hydroxide, which most drain cleaners have in them, there we go, that's a better view, can take the fat molecule and cut off the glycerides to actually form a salt chain of soap. These fatty acids that make the soap now have newer properties of being the lipophilic and hydrophilic. So, now, how do we get from there? Well, we have we came from soap making using ash. Back in the day, the Romans actually had a river that was near a volcano, um, and they washed dishes in it. And because it was so ashy, from the burns and pits and stuff, it combined with animal fats to actually make a soap in the pottery, or so they think. Soap's been with us for many, many years. Um, the actual chemical formula, though, hydro, sodium hydroxide and potassium hydroxide, it's very simple to make. Sodium hydroxide you can make by taking electrolysis and running it through running electrical current through salt water and making sodium hydroxide that way. Or you could throw sodium in water and make it that way. Potassium hydroxide is the one that's more akin to wood ash. So you would take hardwood, you would burn it, and since it contains a lot of potassium, you take that ash and you put it in a pot, and then you'd mix it with water. Now the potassium would then start bonding with the water molecules and forming potassium hydroxide. This potassium hydroxide then will go and attack the fat. Once it's boiled down, it's turned to lye. And once that lye is applied to fat, it basically eats it apart and turns it into a soap. So there's two simple processes: the cold process and the hard process. Sorry, the cold and hot process. The cold process is very, very, very home do it yourself. You take some good fats like a coconut oil, or vegetable oil, olive oil, and you put them in a pot and you mix them together and you add a little sodium hydroxide, and then you take that and you mix, 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 and you break it down, and eventually you mold it and you make your bar. Simple, right there. The hot process is you take your lye, your sodium hydroxide, you add it to your fats, and you heat this up to 316 degrees, and that basically causes it to instantly saponify. It causes it all to happen at once. You basically have 30 seconds to start your molds because your soap is starting to hard just that quick. Um, And there's two types of soap. You can make soft soap and you can make hard soap. These two properties. Hard soap does not clean as well because it doesn't make as many bubbles. It doesn't saponify. It doesn't emulsify. It That's more like your coconut oil. If you made soap just with coconut oil or with wax, you'd make a hard soap. It would last forever, but it's terrible at cleaning. Then on the other side, you have soft soaps, which are amazing at cleaning. Like they just lift everything up, but they will just go. You'll burn through them in 6 or 7 washes. That's mainly your peanut oil, your uh, olive oil. What you want is a soap that has properties of both, and you can kind of play around with it. So you can have additives too. You can have pumice to make it more rough and abrasive and take away heavier dirts and contaminants. You can have wood fiber to give it also a little bit more rough. You can put kaolin clay in it, which will make it smoother on the skin and also holds smell a lot better. You can use certain perfumes like citrus oil to give it a very aromatic effect to it. You can blend it a lot of different ways. Soap is amazing in its just general uniqueness in how we use it. So I say to you, don't be afraid, do it. Don't be afraid to play around with soap. Don't be afraid to make it. It's easy. It can be dangerous with the lye because it can burn you. But if you take certain steps, wear gloves, protection, and you don't get it in your eyes, realize you're dealing with a caustic chemical, it's amazing. It's fun. It's great. Be an at home chemist. Try making soap. Now that I've explained the soap process, what soap is, I hope I've given you a better understanding of just how unique and great it is to us and how it serves us at making us clean. I'm Dennis Hunter. I appreciate you coming out to listen to me. Thank you.